Hello friends, welcome to our YouTube channel. In this discussion, we're continuing with the binomial expansions. We want to look at these three expressions that we have and see how we can expand them. In this discussion, we're particularly looking at the Pascal's triangle, which was introduced in the previous video, and in that video only covered the part of how to form it. But in this discussion, we want to solve questions using the same binomial. The Pascal's triangle. Sorry. Now, one thing that you need to note is given you have a binomial, and a binomial we know to say is in the form a plus b under parenthesis raised to the power n. Now here, what you have is whatever power of n is there, when you expand it, the binomial will increase, or will simply give you the number of terms which are n plus 1. So when you expand that same binomial, which has a power of n, the expanded version of the same binomial simply be n plus 1, meaning that if the binomial has a power of 5, when we expand it, you're only going to get 6 terms. So it only increases by 1 depending on the power that is there. So this is what we have. Now let's look at the questions. We start with A. So our A, we start with A. Our A is a plus b. Then you can write brackets there raised to the power 3. So this is our binomial expression. Now to expand this, we're going to simply use the Pascal's triangle, which you know how to form. If you don't know, I'm going to send a link to the video where we formed the same Pascal's triangle. So these are the coefficients that we're going to use for us to simply expand this given binomial expression. And if you check, the number of coefficients that are here the same ones as the ones we have there as n plus 1. So let's start our expansion. So this is the power 3. I will say equal to, what you do is you get the first coefficient, which is 1, then multiply it with the first term, which is a. Now a will be raised to the power of 3. It will be reducing by 1, so it will be descending until it reaches a power of 0, while b will be ascending, but to start from 0 as in terms of the exponent. So our b will be raised to the power of 0. You are multiplying a and b there. Then you say plus. You come to the second coefficient, which is a 3. Then you say multiply by a. So it will reduce by 1, so it will be 2. Then times b. Now here to be the power 1. Then you say plus. Next one is 3. So you raise it, you multiply with a, the power 1. Because it is reducing, then b is increasing. So it will now be 2. Our b will be raised to the power of 2. Then you add the next one, which will be the last coefficient, which is a 1. Multiply by a. A will be to the power 0. While our b will now be to the power 3. So since our coefficients are done, we stop the expansion. Now we simplify. So this will just give us a to the power 3 when you multiply everything there. Then you have plus 3a squared b. Then you say plus 3ab squared. Then plus the last one, which is b to the power 3. And this is the expanded expression. So now going to b, we have 2x plus y, which is raised to the power 3. Let's see how we can expand this. Now, remembering that this is in the form a plus b, or raised to the power of n, where when we compare, we get a to be 2x, our b to be y, and our n to be 3. So this will therefore give us a to be 2x, b to be y, and n to be 3. Now let's see how we expand. So now what we do is we use the coefficients for a Pascal's triangle. So we can form a Pascal's triangle quickly. So this is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So we're using the last set because our power is 3. Now let's write our binomial expression, which is raised to the power of 3. So like what we did with a, here we're going to have the first coefficient to multiply with the first part, which is 2x, to the power of 3. Then b, which is y, will be raised to the power of 0, and it will be increasing by 1. Then now come to 3, multiply with 2x, here to be to the power 2, it is reducing by 1, then y will be to the power 1. Then you add. Then now you're going to have 3 to multiply with the first part, which is 2x, to the power of 1 here, then times y to the power of 2. Then plus the last part, which is 1, times 2x to the power of 0, then times y to the power of 3. Now this will therefore give us 2 to the power of 3 will give us 8. So we get the first part to be 8x cubed, since the first and the last are all ones. Then say plus 2 to the power of 2, that is 4. Then 4 times 3 will give us a 12. Then x squared. Then to multiply with y, then say plus. The next one is 2 times 3, that is 6x. Then y squared. Then plus. So the first and the second just ones, then we have y to the power 3. Okay, so now we look at part C. So part C is given as 3a minus 2b. That is minus 2b. Everything raised to the power of 5. So here, our a, comparing with what the binomial expression is 3a. You're not equating this, then b is simply negative 2b, and c is, n is 5, sorry, not c. Now we form our triangle, since we're looking at the Pascal's triangle. And this one goes like this: 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So we're using the last set of coefficients in expanding this. So we write our binomial expression again, which is 3a minus 2b, all raised to the power of 5. So we use these coefficients. So this will be, we'll get the first one, which is 1, multiply to the first part, which is 3a, then raise to the power of 5. Then you get even the negative also, so it will be negative 2b raised to the power of 0. Then you add. You're going to have the second coefficient, which is 5, to multiply with 3a, everything raised to the power, so it here to be the power 4. Then you say negative 2b raised to the power of 1. Then you say plus. The next one is 10 to multiply with 3a to the power of 3, then times negative 2b to the power of 2. Then you add with the next one, which is 10. Then this will give us 3a to the power of 2 times negative 2b raised to the power of 3. Then you come to the next one, which is 5, multiply with 3a raised to the power of 1 times negative 2b raised to the power of 4. Then you come to the last part, which is 1, multiply with 3a raised to the power of 0, then negative 2b raised to the power of 5. So this is what we get. Then we now continue with the simplification process. So this is 3 to the power 5, which gives us, when we multiply there, 3 to the power 5, this will give us 243. Then you say 8 to the power of 3, to the power 5, sorry. Then the next one now is 3 to the power of 4, we get 81. Then you multiply the 81 with 5. So 81 times 5 will give us 405. Now this 405 will multiply with negative 2 times negative 2, which will give us a negative 810. So we are going to get a negative 810 a to the power of 4 then B. Now I got the next one. This is 3 to the power of 3, which is giving us 27. Then now 27 times 10 will give us 270. Now not forgetting that we have negative 2 to the power 2, which is just a positive 4. So we're going to have 4 times 270. 4 times 270 will give us 1080. So we're going to have a positive 1080. Then you have 8 to the power of 3, B to the power of 2. Now coming to the next one. So this one, it won't be a positive, so it will just be a negative. So the first term is always positive, if in a case I have a negative. So I have positive, negative, positive, negative, just like that, depending on where you're ending. So this will definitely be a negative. Now I have 3 to the power 2, which is a 9. 9 times 10 will give us a 90. Now 90 will multiply with 3, I have a negative 2 to the power 3, which is 8. So negative 8. So we're going to have 90 times negative 8, which will end up giving us negative 720. So get minus 720. And this will be a squared, then times b cubed. Okay, we got the next one. Now this is 5 times 3a, which is just 15a. Then I have negative 2 to the power 4, which is a 16. So we're going to have 15 times 16. So this will give us a positive 240. We get positive 240 upon working out the numbers. So I have positive 240, then multiply by a, then times b to the power 4. Then you come to the next one. So this one, the first two will just be ones. Then I have negative 2 to the power 5 will give us a negative 32. So I got negative 32 b to the power 5. And this is how you answer question C. Thank you very much for watching this video. Please consider subscribing to our YouTube channel.